Good morning to all. My name is Shyam. I am the faculty of chemistry. Dear students, today we are going to discussing about the chapter of solutions. The chapter of solutions. The chapter of solutions. Okay. Na? Before we going to the concept, you will discuss about some basic fundamentals regarding the solution chapter for the better understanding. Okay, now, so you know very well our universe is classified into two types. Our universe is classified into two types. One is matter, second one is radiation. One is matter, second one is radiation. So what is matter? Things which have mass and occupy space is called matter. In this universe, everything should be considered as a matter. For suppose, if you take the marker is the example of matter. How can you say? Because it has some mass, and occupies space. That's why the marker is considered as a matter. Even our cell phone, pen, book, pencil, whatever it is, everything should be considered as a matter. Because, so for suppose, if you take myself also considered as a matter because I have some mass and occupy some space. And yourself also considered as a matter because you have some mass and occupy space. So that's why in this universe, everything should be considered as a matter. What is radiation? Things doesn't have mass, only occupy space. It is called radiation. Okay, now matter again classified into several types based on nature. Okay, now based on physical nature of the matter, matter should be classified into 5 types. First one is solid, second one is liquid, third one is gas, fourth one is plasma, and again fifth one is Bose condensed state or Bose Einstein state. Bose condensed state or Bose Einstein state. Again, based on chemical nature of the matter should be classified into 2 types. One is pure substances, second one is impure substances. Second one is impure substances. So elements and compounds belongs to pure substances. Mixers are belongs to impure substances. These mixers again classified into 2 types. One is homogeneous mixtures, second one is heterogeneous mixtures. One is homogeneous mixture, second one is heterogeneous mixture. What is homogeneous mixture? For the better understanding, I will give one example. For example, take a test tube with 100 ml of water, and add 5 grams of sugar. Okay, so after dissolution of sugar in a water, the solution looks like a same phase or single phase. That means the sugar particles are uniformly distributed throughout the solution. Uniform distribution takes place. These type of solutions are called homogeneous solutions or homogeneous mixers. Best example, glucose in water, salt in water, sugar in water. What about heterogeneous mixture? Oil in water. 2 different phases are observed. Oil in water, different examples. Okay, now oil in water, pebbles in water, stones in water. These are the examples of the heterogeneous mixtures. So what about solution? What is solution? Solution is the homogeneous mixture. Solution is the homogeneous mixtures. And homogeneous mixtures are called solutions. Okay, now. So what is solution? Solution is nothing but. What is the definition of solution? Solution is nothing but. It is the composition of 2 or more substances. It is the composition of 2 or more substances. It may be varied in a certain limits. This is called solution. Solution. Solution is nothing but solution is then defined as a homogeneous mixture of two or more substances whose composition may be varied in a certain limits is called solution. So what are the characteristics of solution? Characteristics of solution. What are the characteristics of solution? Nana? What is the first characteristic? Nana? What is the first characteristic? It is the homogeneous mixture. Nana. It is the homogeneous mixture. Solutions are called homogeneous mixtures. So, formation of solution is the physical change. Formation of solution is a physical change. Physical change, but not a chemical change. But not a chemical change. Chemical change. You know very well what is the physical change, what is the chemical change, what is the difference between two them. Okay now. So formation of solution is a physical change but not a chemical change. Okay now. So this is the second characteristic of the solution. What is the third characteristics of solution? The solute can be separated from the solvent by filtration method only. Okay now. Solute can be separated by the solvent by which process? Filtration, adsorption or crystallization. By using these methods, solute can be separated from the solvent. Remaining all the metals are not used. Why? Because this is the physical change. This is the physical change. So that's why these are the characteristics of the solutions. These are the characteristics of the solution. Next, types of solutions. Types of solutions or classification of solutions. Classification of solutions. Okay, now first classification 1. Classification 1. Solutions are classified into several types based on number of components. Based on number of components. Based on number of components. Based on number of components, the solutions are classified into three types. The solutions are classified into three types. One is binary solutions. Second one is tertiary solutions. Third one is quaternary solutions. Based on number of components present in a solution, the solutions are classified into three types. One is binary solution, second one is tertiary solution, fourth one is quaternary solution. Okay now. So generally solutions are made up of two components. Two components. Major components. What are that? One is solute, another one is solvent. One is solute, another one is solvent. What is solute, Nana? The lesser quantity present in a solution is called solute. The larger quantity present in a solution is called solvent, Nana. Solvent. Okay now. For suppose, if you take test tube, this is the water and add some amount of glucose. Okay now. So this is the solution of glucose in water. So in glucose water, glucose is the lesser quantity. In glucose solution, glucose is the lesser quantity. So water is the larger quantity. Here, water acts as a solvent, glucose acts as a solute. That means the lesser quantity present in a solution is called solute. The larger quantity present in a solution is called solvent. So generally solutions are made up of two components. One is solute and one is solvent. This is the another phenomenon. But here, based on number of components, based on number of components, solutions are classified into three types. One is binary solution, second one is tertiary solution, third one is quaternary solution. What about binary solution? The solutions are contains only two components. Only two components. So these type of solutions are called binary solution. These type of solutions are called binary solutions. Okay now. So in binary solutions, one solute and one solvent is available. Best example, sugar in water. Sugar in water. So binary solution, what are the binary solutions? The solution contains only two components. One is solute, another one is solvent. So one solute, another solvent. Best example, sugar in water. The solution contains three components. Three components. These are called tertiary solutions. That means in this case there are two solutes and one solvent is available. Best example, sugar, lemon and water. No problem. Or salt, your wish. So what are the quaternary compounds? The solution contains four components. That means here three solutes and one solvent. Best example, sugar, KCl, water, or some amount of add salt also. Okay now. So in these tertiary solutions, okay now, contains only four components. So based on the number of components in a solutions are classified into three types. One is binary solution, second one is tertiary solution, third one is quaternary solution. Binary solution contains two components, one solute, one solvent. Quaternary solution contains four components, three solutes, one component. And tertiary solution contains three components, two solutes and one solvent. So these are the classification 1. Next, classification 2. Next one, classification 2. Based on physical state of the solutions are classified into several types. Based on physical state of the matter. Based on physical state of matter. Very, very important. No? So based on physical state of matter should be generally based on physical state of matter should be classified into how many types? Majorly. Generally 5 types, majorly 3 types. One is solid, second one liquid, third one is gas. So base classification 2. Based on physical state of matter should be classified into generally 9 types. 9 types. Okay now, what are the will be discussed now. Okay now. So classification 2, what is that? Based on physical state of matter should be classified into 3 types. One is solid, second one is liquid, third one is gases. First one, solid type of solutions. Now you understand? Generally, based on physical state of matter should be classified into 3 types. One is solid, second one is liquid, third one is gas. So solid in liquid type, solid in gas type, like this. Each one again classified into 3 types. Overall 9 types. Okay na? So it is discussed one by one. First one, solid type of solution. In solid type of solution, solid act as a solvent. In solid type of solution, solid act as a solvent. This is again classified into 3 types. First one, solid in solid type. Second one, liquid in solid type. Third one, gas in solid type. Gas in solid type. Here solid act as a solvent. Here solid act as a solvent. In solid type of solution, solid act as a solvent. So best example, solid in solid type of solutions. Solid in solid type of solutions. Okay, now best example, metal alloys. Metal alloys. Brass, best example, brass. For example, brass with a combination of zinc and copper. 30% of zinc and 70% of copper is mixed to each other to form a brass, which is the lesser quantity of zinc. That's why zinc act as a solute and copper act as a solvent. Both are solids. So this is the example of solid in solid type of solutions. Solid in solid type of solution. What about liquid in solid type of solution? Liquid in solid type of solution, best example is amalgams. Okay, ma'am. Liquid in solid type of solutions, amalgams. Okay, now for example, mercury in gold. Mercury is a liquid, gold is a solid. Gold is a solid. This is the solute, this is the solvent. Next, gas in solid type of solution. Gas in solid type of solution. The alkylation of H2 over the palladium. Over the palladium. Over the palladium. Here, H2 is the gas. PD is the palladium is the solid. So this is the example of gas in liquid type of solutions. Gas in solid type of solutions. Okay, ma'am. So solid type of solutions, ma'am. Solid type of solution again classified in three types: solid in solid type, liquid in solid type, gas in solid type. So solid in solid type, best example metal alloys, best example brass. Liquid in gas type, liquid in solid type of solution, amalgams, and gas in solid type of solutions. Example is alkylation of H2 over the palladium, and H2 gas mixed with palladium metal. So this is the examples of the gas in solid type. Okay, now next one, liquid type of solution. Next one, liquid type of solutions. Next one, liquid type of solutions. Liquid type of solutions. Okay, ma'am. Liquid type of solutions. So here liquid is act as a solvent. Liquid is act as a solvent. Okay, ma'am. Liquid is act as a solvent. Okay, now but again classified into three types: liquid, solid in liquid type, solid in liquid type, and again liquid in liquid type, and third one, gas in liquid type. Gas in liquid type of solution. Example, solid in liquid type of sugar in water. Sugar in water. Liquid in liquid type of solution, alcohol in water. Alcohol in water. Third one, gas in liquid type of solution, soda water. Soda water. Soda water means CO2 in water. CO2 in water. These are the liquid in liquid type of solutions. Okay. Next one, gas type of solutions. Gas type of solutions. Gas type of solutions. Gas type of solutions. Here, gas is act as a solvent. Gas is act as a solvent. So, for example, solid in gas, again solid in gas, second classification, liquid in gas, third one, gas in gas, solid in gas, liquid in gas, and gas in gas type of solution. Solid in gas example carbon in air, camphor in air. These are the examples of the solid in gas type of solutions. So solid in gas type of solution, carbon in air, or camphor, sublimation, best example, camphor in air. Okay, so these are the examples of the solid in gas type of solutions. Next, liquid in gas type of solutions. Liquid in gas type of solutions. What is the best examples? Liquid in gas type of solution. Moisture in air. What is that? Moisture in air. moisture in air. So, and moisture in air, fog, these are the examples of the liquid in gas type of solutions. At the same time, chloroform mixed with nitrogen gas. Chloroform mixed with nitrogen gas. These are the examples of the liquid in gases type of solution. So solid in gas type of solution, liquid in gas type of solutions. Next, gas in gas type of solution, air in all gases present in air. Best example, nitrogen is 78%, remaining all gases are present in 21%. So this is the gas in gas type of solution. Based on physical nature of the matter should be classified into 9 types: solid type of solutions, liquid type of solutions, and gas in gas type of solutions. So what about liquid in liquid type of solution? Liquid in gas, solid in liquid, liquid in liquid, gas in liquid. What is the gas type of solutions? Gas is act as a solvent, solid in gas, liquid in gas, gas in gas. These are the 9 table. Okay, na? 9 types of solutions. Okay, na? This is the classification 2. Classification 2. Next one, classification 3. Classification 3. Classification 3. So based on amount of solvent, amount of solute. Based on amount of solute present in a solution, the solutions are classified into 3 types. One is saturated solution, saturated. Second one is unsaturated. Third one is supersaturated. Supersaturated. For the better understanding, I will give one example. For example, if you take one test tube with 100 ml of water, take test tube with 100 ml of water, 100 ml of water. For suppose 5 grams of sugar is sufficient for the dissolution of 100 ml of water. 5 grams of sugar is sufficient. That means no more solute can be required for the dilution. Is called saturated state. What is the saturated solution? What is the saturated solution? So for suppose 100 ml of water is sufficient for the 5 grams of sugar is sufficient for the dissolution of 100 ml of water. That means no more solute can be required. No more solute can be dissolved in a solution at given temperature and pressure is called saturated solution. Okay, Rama? Next, what about unsaturated solution? The lesser amount of solute required when compared to saturated level. Is called unsaturated solutions. What about the supersaturated solution? More amount of solute required than saturated level is called supersaturated level. For the better understanding, I will give you an example. For suppose in a breakfast, one student, 5 idli is sufficient for 5 idli is enough for his breakfast. Okay, now so that means the boy is in saturated level. But actually, I will give 4 idli. That means he is in unsaturated level. And sometimes I will give 6 idlis. That means he is in a supersaturated level. He is a supersaturated level. That means what is the saturated level? No more solute can be dissolved in a solution at given temperature and pressure is called saturated solution. What about unsaturated solution? Lesser amount of the solute is required than when compared to saturated level. That is called at given temperature and pressure is called unsaturated solution. What about supersaturated solution? More amount of solute required when compared to saturated level. Okay, na? When compared to saturated level at given temperature and pressure is called saturated, unsaturated, and supersaturated solutions. Okay, na? These are the classification 3. Next, classification 4. So classification 4 amount of classification based on relative amount of solvent. amount of solvent based on relative amount of solvent. Okay na, solutions are classified into three types na. Solutions are classified into three types. Okay na, based on relative amount of solution. Relative amount of solution is called based on relative amount of solution anna. So the solutions are again classified into two types anna. One is concentrated solutions, second one is diluted solution. One is concentrated solution, second one is dilute solutions. One is concentrated solution, second one is dilute solutions. Here, what is concentrated solution and what is dilute solution? Here, one thing is observed. Relative means, what is the relative? Relative means comparison. Relative means comparison. Without comparison, you can't say here. Okay, now the solute contains relatively very small quantity of solute. Very small quantity. Small. ఇది large content. What is constant? Sorry, this is the large quantity. This is the small quantity. So what is the dilute solutions? Dilute solutions are nothing but a solution contain relatively very small quantity of solute. Very small quantity of solute. Here very large quantity of solute particles. So these are the concentrated solution. These are the dilute solutions. So based on relative quantity of solution, the solutions are classified in two types. One is concentrated, another one is diluted. Okay, nama? The solution contain very larger quantity of solute particle. The solutions are called concentrated solution. The solution contains very small quantity of solute particle. These are called dilute solutions. Dilute solutions. Next, based on classification 5. Classification 5. Okay, now classification 5 based on particle size. Based on particle size, the solutions are classified into three types. One is true solution, second one is colloidal solution, third one is suspension solution. True solution, colloidal solution, and suspension solution. Now, what is true solution? What is colloidal solution? What is suspension solution? Will be discussed in later. Okay. So classification 5. Classification 6. It is based on amount of solvent. Based on amount of solvent, solutions are classified into two types. First one is aqueous solution. Second one is non-aqueous solution. In aqueous solution, water is act as a solvent. So other than water is act as a solvent means non-aqueous solution. Best example, ammonical solutions, carbon tetrachloride solution, benzene solution. These are the examples of the non-aqueous solution. Water is act as a solvent. The solutions are called ammonical solution. Other than water is act as a solvent is called a non-aqueous solution. Alcoholic solution, ammonical solutions. These are the examples of the non-aqueous solutions. Okay, now these are the types of solutions. Okay, now next one, what is concentration? What are the ways to represent the concentration? Ways of expressing the concentration. Different types of ways are there in our concept. Different concentration terms will be there. Normality, weight percentage, volume percentage. Next, weight by volume percentage, molarity, normality, mole fraction, formality. These will be discussed. Okay, now next one.